So let's recap a little bit about what we did last time. Um, let's get a scatter plot here where my high school people and my college GPA and see if there's some type of correlation. And just by looking at it, you can tell it's a positive correlation. Um, and it's pretty strongly positive, but some of these points are going to be pretty far away from my line. We want them to look more like a line, the stronger that they are. To get that regression line, I believe it's analyze, menu analyze, and there's our regression line. We're going to stick with this one, a plus bx, and it plops that regression line in. And we can actually move this around a little bit so that we can see it a little bit better. And on the AP exam, we're not going to actually be talking specifically about what you should round to, but maybe like the thousands place, the hundredths place, would be a good way to round. But for this, I mean, I'm just going to use the whole entire thing. I'm not going to round anything for right now. So this gives us our regression line. We also talked a little bit in the last class about residuals. So residual was the distance away that a point is from where it's predicted to be, and the predicted value is this line here. So the one, it seems like to me, with the biggest residual would be a point like this one, because it's the farthest distance away. It's predicted to be around 2.2, and it's really showing up at about 2.8. So that is a pretty big residual there. And I believe we calculated the residuals one per group in the last class. I'm actually going to go back to my table, and I want you to follow along, and I want you to build this as well in your Nspire calculator. And then come back to this anytime you need to remind yourself on how to do this in the calculator. So I put my high school GPAs here and my college GPAs here, because my explanatory variable is you're trying to see if that can predict what's going to happen for the people in college. And that's the way it works. The response is the predicted value over here of what's going to happen in college. And I copied the table in. And if you need the table, it's also on in the Moodle under the last class, the scatter plot to do as a class. And I want you to have that in your calculator. And then let's see if your calculator can figure some things out. Because if you didn't realize, this bar here that's gray, this is actually a formula bar. So it will calculate things for you. I'm going to add in my regression line over here and get that information over here. If I go to Menu, Statistics, Stat Calculations, I'm not actually going to get my two variable statistics. I'm going to get my linear regression statistics in this a plus bx form. And my x is my high school. My y is my college, because I'm trying to predict what's going to happen in college. My results will be in column D. That's fine. And if you see here, this is the very similar equation that I have in my scatter plot. 0.433883. 0.433883. My B value, my slope, 0.64652. 0.64652. Same thing. So what I'm actually going to do is I'm going to tell my calculator to calculate all of the predicted values. I'm going to try to calculate what my predicted college values would be. So basically, not what my actual values are, not where these points are, but where are they supposed to be? Where are they predicted to be? This one's predicted to be up here. This one's predicted to be down here. What are these actual points? And a lot of people, when they were calculating their residuals, they were calculating what that point is. And the residual was just the actual take away the predicted value, the actual minus the predicted value. So right now I'm just trying to calculate what the predicted values are. So I'm going to do my predicted college. That's going to be my title. And this is actually a formula bar, so I could put equals, and it's going to say predicted college equals, and it is my linear regression line, my 0.433883 plus my slope, 0.64652 times my x value. And I don't think you actually can put x. What I've been doing is I've been putting high for my high school. My column over here, my A column has high school. That's what I'm putting in for my x. When I click this, this is actually giving me all of the predicted values. So for somebody who has a high school GPA of a 2.0, it's predicted they have a 1.7 GPA in college. And the actual, someone had an actual 1.6. So these are the values for 2.2 and what's predicted and the actual. So I'm actually going to make another line that says residuals. And I'm going to tell it to calculate something. Oh, apparently when I open that up, it puts the equal sign in there for me. So my residuals is equal to my actual value, take away my predicted value. My actual value over there was under the title college. And my predicted value was under predict college. And here's all the residuals. And I believe we calculated these in class. But these are them to, 6 decimal places. And keep in mind, remember the sum of them all would be 0. And I think if I summed this, I think I did that before, and it came out to 0.000002. But that's just because of rounding. It should always be 0. So the goal for all this was to calculate a residual plot. And a residual plot is basically a similar plot to this, where we're going to have our high school along the bottom. We're going to have but instead of college up top, we're going to have residuals up top. Remember, the residuals are supposed to be at 0. This is the mean. When we look at the residual plot, there's a few things that we're looking for specifically. There shouldn't be a pattern. When you look at this, it should look pretty random as far as the selections of the where the variables are landing. If you notice that there's a curved pattern, like if all the points are going around like this in a curve, then it shows that the relationship is not linear. So a line of best fit isn't really going to fit it because it's curved data. And if the residual plot shows increasing spread as x values get larger, then the predictions as x gets larger, they are less accurate. And let me change some of this around so that you can see. So for example, for something like this, where to the left, they're very close to the regression or the mean of 0, but then as you're getting out further, they're getting further away. This means that your spread is getting larger as your x values are getting larger. So when you're starting to make your predictions around here, you're going to be less accurate because right around here you have less of a residual, which is kind of like your error. Here there's not that much error, and here there's such a great error. So as your x values get larger, your predictions are going to be less accurate. There's one other thing that you should know, and that is that the residual should be pretty small. You shouldn't have too many big gaps. You should have, they should be pretty relatively close to that mean and pretty small. Now, what does pretty small mean? There's actually a calculation that you can do. And the calculation is to calculate the S. And the S is the standard deviation of the residuals. And it tells us how far off our predictions are. And it uses the units from the Y. So if we were trying to figure out GPA, it would stay within the GPA range. If the Y value was weight, it would stay with pounds or kilograms. And this is where that sum of the squares over the residuals comes into play. And your calculator will display that. And you divide by n minus 2 and take the square root of it. And that gives you the standard deviation of the residuals. And that can tell you how far off things are.